Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's a problem for today for exam LTAM. Diana, who is now 65 years old, is entering a continuing care retirement community, CCRC, under a full life care Type A contract. She will move into an independent living unit. Diana pays a one-time fee of F immediately on entry and a level monthly fee of M at the start of each month that she is in the CCRC, including the first. You are given the entry fee is equal to 25% of the expected present value of all future costs. The CCRC operates three types of accommodations. They are listed here with the monthly costs incurred at the beginning of the month by the CCRC for each resident in each category. Independent Living Unit, or ILU, $3,000. Assisted Living Unit, or ALU, $7,500. Specialized Nursing Facility, SNF, $15,000. Interest rate is 5%. The monthly fee M is determined so that the expected present value of the monthly cost is equal to the expected present value of M plus the expected present value of F. The CCRC uses the following multiple state model to determine the fee structure, and the states are 0, 1, 2, and 3, and those are ILU, ALU, and SNF, and the observing state of being dead, state 3. The following actuarial functions have been evaluated for the model at interest rate of 5%, and we have a double dot annuity functions which are payable monthly, starting in state 0 and paid while in state 0, state 1, and state 2, at starting at ages 65 and 70. Then annuities also monthly starting in state 1, just like that. And then life insurance for starting in state 0 and ending up in state 3, death, with payment at the end of the month of death. Question A. You are given that F is 150,000 to the nearest 1,000. Calculate F to the nearest 10. 2. Calculate M. B. Calculate 5V0, the reserve 5 years after entry, assuming Diana is in state 0. 2. Calculate 5V1, the reserve 5 years after entry, assuming Diana is in state 1. You're also given the probability of survival in stage 0 at age 69 and 11/12 for the next 1/12 of the year is 0.94937, and the probability of transitioning to state 1 under the same circumstances is 0.00906, and probability of transitioning into state 2 under the same circumstances is 0.00003. Calculate the reserve in stage 0 at policy duration 4 and 11/12, or duration since admission of 4 and 11/12. The CCRC introduces an option under which 50% of the initial fee is refunded at the end of the month of death. The revised entry fee F will be equal to 25% of the expected present value of all future costs plus the refund. The revised monthly fee M is determined so that the expected present value of the monthly costs plus the expected present value of the refund benefit are equal to the expected present value of M plus the expected present value of F. D. Calculate the revised entry fee assuming Diana selects the refund option. And part 2, calculate the revised monthly fee assuming Diana selects this option. Part 3, state with reasons whether 5V0 will increase, decrease, or stay the same under the 50% refund contract. And here's a solution. Part A, Part 1, the expected present value of future costs is 12 times 3,000 times A.6500 upper 12. And that's the costs in state 0, plus 12 times 7,500 times A.65 upper 1201. That's in state 1. Plus 12 times 15,000 times A.65 upper 1202. And now all of these annuities present values are given, actuarial present values are given in the table, so we just plug them in and calculate this to be about 600,321.60. F is 25% of this value, so it is approximately 150,080.40. Part 2 of A, the monthly fee M satisfies the condition that 12 times M times A.65 upper 1200 plus A.65 01 upper 12 plus A.65 upper 1202, which those annuity values are given, so this is 12 M times the sum of the values of those annuities, that's equal to 0.75 times 600,321.60, and therefore M can be found because this is a linear equation in which this is the only unknown, and M is equal to 0.75 times 600,321.60 over 12 times sum of the actuarial present values of 3 annuities, so 11.4106 plus 1.357 plus 0.3745, and that's approximately 2,854.95. Part B, Part 1, the reserve is the expected present value of future benefits minus the expected present value of future premiums, which is the fees paid are the premiums for this. And that's equal to 12 times 3,000 times A.70 upper 1200, 70, because it's 10 years into the policy, or into the admission, she is 70, plus 12 times 7,500 times A.70 upper 1201, plus 12 times 15,000 times A.70 upper 1202, minus 12 times 2,854.95, that's the monthly fee, times the sum of the present values of 3 annuities, which we already worked with, given in the table. So now we just plug in all these numbers, do the calculation, and we get approximately 183,561.86. For the reserve in state 1, we have the reserve equal to 12 times 7,500 times A.70 11, referring to starting in state 1 and being paid while in state 1, plus 12,000 times 15,000 times A.70 upper 1212, minus 12 times 2,854.95 times the sum of 2 annuities this time, the one starting in state 1 and paid while in state 1, and the one starting in state 1 and paid while in state 2. All of these numbers are given in the table. We plug them in to the calculation and get approximately 712,339.91. For Part C, we use the recursive reserve formula for and 1112V plus the reserve at policy duration plus M minus 3,000 times 1.05 to the 112 is equal to 112 P69 and 111200 times the reserve in state 0 at policy duration 5 plus 112 P69 and 11201 times 5V1 plus 112 times P69 and 111202 times 5V2. and we know the reserves in state 0 and state 1, and we calculate 5V2 as 12 times 15,000 minus 2,854.95 times A double dot 70 upper 12 22. That's that annuity is given in the table, so we plug that in and get approximately 1,340,244.61. Also, M minus 3,000 is approximately 2,854.95 minus 3,000, so it's negative 145.05. We conclude then that the reserve at policy duration 4 and 11/12 is 145.05 plus 0.94937 times 183,561.86 plus 0.00906 times 712,339.91 plus 0.00003 times 1,340,244.61 times 1.05 to a negative 1/12. That comes from the formula at the very top, the very first formula in C, where we solve it for 4 and 11/12 V, and that M minus 3,000, basically we calculated to be negative 145.05. If we multiply both sides by 1.05 to a negative 1/12, then that moves to the right-hand side. And then if we move M minus 3,000 to the other side, the negative becomes positive. So that's why we have this 145.05. So basically solve this as an equation in which 4 in 11/12 V is the unknown. And the answer is 180,173.71. Part D, part 1, we can write the new equation of value for F as F is equal to 0.25 times 600,231.60 plus 0.5 times F times A65 upper 1203 for payment upon death. That's 0.25 times 600,321.60 plus 0.5 times F times 0.3601. And this becomes a straightforward linear equation in F once we multiply it out. And F, we solve it for F. F is equal to 150,080.40 over 1 minus 0.0450,125, and it's approximately 154.31. Now, for part 2, the new equation of value for M is 12M times A double dot 65 upper 1200 plus A double dot 65 upper 1201 plus A double dot 65 upper 1202. That's equal to 0.75 times 600,321.60 plus 0.5 F A65 up 1203, and therefore we solve this for M, and all of the terms that are in there are now given, so we plug them in and get approximately 2,989.52. And part 3, the time 5 reserve in state 0 will increase because it now, in addition to the original time 5 reserve, includes the amount needed to support 75% of the cost of the refund of fees. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.